Hi everyone, let's talk about the Pythagorean Theorem. The Pythagorean Theorem is a statement about the sides of a right triangle. And some of you might remember from previous class the equation a squared plus b squared equals c squared. That's the kind of important part of the Pythagorean Theorem. The theorem is named after this guy, Pythagoras, who was an ancient Greek mathematician and philosopher. He wasn't the only one to discover it. There were a lot of cultures in ancient times that knew about this theorem. It just so happens that we named it after him. Okay? So, before we get into examples of using the theorem, I just wanted to define a couple of words for you. We're going to be talking about sides of a right triangle. And they have special names. The hypotenuse, this crazy word here, is the name we're going to use for the longest side. Okay? And the other two sides we're just going to call plain old legs. Okay? So let me show you an example. If I draw out kind of the typical right triangle, marking that I have a right angle here, the hypotenuse is always the longest side. Okay. How do I recognize the hypotenuse? Well, the hypotenuse is always opposite of the right angle. What do I mean by that? Look at what the right angle is, go across the triangle, and we'll get to the hypotenuse. Okay. The two sides that are attached to the right angle, or that make up the right angle, these are the sides that we call legs. So this is a leg, let's say. And this is a leg. Now, it's important to keep that in mind even when the right triangle is rotated into a different position. Okay? So if I drew the right triangle like this with a right angle over here, to find the hypotenuse, I'm still going to go across the triangle. So the hypotenuse is over here now. And the legs are here and here. Okay. Just one more. If somehow I drew the right triangle in a strange way like this, where I put the right angle over here, look for the right angle, go across the triangle, we'll hit the hypotenuse. Okay, so the hypotenuse in this example is down here, okay, the legs are over here and here. Okay? So, what does the Pythagorean theorem tell us? Well, the theorem says that for a right triangle, and this is very, very important, only in a right triangle, if we label one of the legs as A, another of the legs as B, and the hypotenuse as C, okay, let's get rid of that, hypotenuse as C, Pythagorean tells us that A squared plus B squared equals C squared. Okay. That is, the length of A squared plus the length of B squared is the length of C squared. Okay. How would we use that? Well, in our first example, let's see. If the legs of a right triangle measure 2 units and 4 units, what is the length of the hypotenuse? Okay, so let's get used to using those words, that vocabulary, the legs and the hypotenuse. I'm going to draw out just a typical right triangle. I can draw it any way I like as long as there's a right angle there. So if the legs of a right triangle measure 2 units and 4 units, that means I have one of the legs equal to 2 units, one of the legs equal to 4 units. What is the length of the hypotenuse? Okay, so it's that side that I'm looking for, the length of this side. Okay. So typically, when I'm working with the Pythagorean theorem, I will label one of the legs as A, one of the legs as B, and I will label the hypotenuse as C. Okay. Let's write this out. The Pythagorean theorem tells me that A squared plus B squared is equal to C squared. And the problem gives me the value of A and the value of B. Okay. Does it matter which one I call A, which one I call B? No, it really doesn't. Okay. But it does matter which one I label the hypotenuse. So A is, I've labeled 2, so 2 squared. B I've labeled 4, 4 squared should be equal to C squared. 2 squared plus 4 squared, that's 4 plus 16. 4 plus 16 is 20. So going up here, I know that C squared is equal to 20. Now look what we have here. We have a quadratic equation. Okay? This is a quadratic equation. To solve the quadratic equation, as we learned today, I'm going to take the square root of both sides. And when I take the square root, I'm going to remember that there's a plus and minus here. I'm going to consider both the positive and negative square root of 20. So, square root of c squared is c. So c could be either positive 2 root 5 or negative 2 root 5. Now, why am I writing them separately like this where I didn't before? Because I want to consider what's the solution to the problem, not just what's the solution to the equation. Now, for this equation, c could be 2 root 5 or negative 2 root 5. But remember, we're dealing with a triangle, and we're trying to find the length of one side. So, looking at c, if c could either be positive 2 root 5 or negative 2 root 5, I'm actually going to reject the solution of negative 2 root 5. Because I know that the length of a side of a triangle can never be negative. So my final answer is that if this triangle has legs of 2 units and 4 units, then the hypotenuse has a length of 2 root 5 units. Alright, let's look at a different example. If the hypotenuse of a right triangle measures 10 units and one of the legs measures 6 units, how long is the remaining side? Okay, just to switch it up a bit, I'm going to draw the right triangle a little differently, just so we can get used to labeling triangles and figuring out which side is which. Remember, the hypotenuse now of a right triangle measures 10 units. Where's the hypotenuse? Opposite the right angle. So the hypotenuse, which I'll go ahead and label C right away, is 10 units. One of the legs measures 6 units. Okay? It doesn't really matter which leg I label 6, but it seems I've drawn this as the shorter one, so maybe I'll label this as 6. And I'll just label it as A. That means I'm left with B, and that's what I'm going to solve for in this example. So, let's write out the Pythagorean theorem. A squared plus B squared is equal to C squared. In this example, I know what A is, 6 squared. I know what C is, so I'm going to square 10. What I'm trying to find is B squared. Okay, so let's work some of this stuff out. 6 squared is 36. We don't know what B squared is yet. 10 squared is 100. Let's make sure we know that it's 6. Okay, now I'm going to subtract 36 from both sides. B squared is equal to 100 minus 36, which is 64. Once again, I have a quadratic equation, so I'm going to take the square root of both sides, remembering the plus and minus here. So B is equal to positive 8, or is equal to negative 8. Once again, I'm dealing with a side of a right triangle, so the lengths of sides can't be negative. So what I conclude is that B has to be 8 units in length. Okay? One more example, example 3. Let's see, what is the measure of side C in the figure below? Okay, so here we have a triangle drawn for us. One side is 3, one side is 4, the last side is C. Okay, now let's be careful here. Ask yourselves, is this a right triangle? Okay, there's no indication to me that this is a right triangle. This doesn't look like a right angle, and there's no symbol drawn here telling me that it's a right angle. So what's the answer to this question? What is the measure of side C in the figure below? I don't know. Or at least we have to say the Pythagorean theorem doesn't apply here. Okay. If you remember, the Pythagorean theorem only works with right triangles. Okay? The Pythagorean theorem only works with right triangles. Okay? Any other triangle, we're going to have to use other methods to solve, and really, you won't be learning those methods until 9th or 10th grade. Okay. Since this video is getting a little bit long, I'm going to skip over Pythagorean triples, so don't worry about answering the question about Pythagorean triples on the sheet tonight. Instead, I'm going to leave you with a question to try for yourself. I've drawn a right triangle here for you. I've labeled two of the legs, one as square root of 7 and one as square root of 2. I want you to find what the measure of C is. Okay? Set up the Pythagorean theorem, set up that equation, and solve that quadratic equation for C and see what you get. I don't recall the actual answer, but I think if you work it out, C is going to be 3 units in length. Okay? So try this problem on your own, bring it into class tomorrow, and we'll discuss these questions.